Hello, everyone, and thank you for joining us today. My name is Gwenn Etourneau, and together with my teammate Daniel Hebberd, we are going to introduce From Code to the Car with GitHub Advanced Security on Tekton CD. So, this is today's agenda. First, we will introduce our company and the product we are working on, and the challenge that we are facing and how we address them. Then, why we decide to go with GitHub Advanced Security and how we integrate within our workflow using Tekton CD.
Thanks very much, Gwenn. You may not have heard of us before. Our company, TRIAD, is a fairly new company based here in Nihonbashi in Tokyo, Japan. We've been around for about 2 years. We've been rapidly growing throughout. It's our goal at TRIAD to blend the best of Silicon Valley innovation with the quality-driven values of a trusted Japanese company in order to create a world-class technology and build the safest car in the world. We believe this is a place where engineers and designers can manifest their dreams into globe-spanning realities. It's our role to build a robust pipeline between research and production in order to accelerate the development and deployment of automated vehicle technology. We have a lot of very exciting projects underway here at TRIAD, and I encourage you to look us up and learn more about what's going on. I've included a bunch of photos of what it's like to work at TRIAD in more relatively normal times. You can see my messy standing desk down there in the bottom left. You can see where Gwenn's team would normally sit in the bottom right. And you can see our next generation usability simulator in the sort of middle bottom there. If you'd like to learn more about what's going on with that, then jump on our website and read more about what's going on. So the product Gwenn and I are working on here at TRIAD is called Irene, and it's our goal with Irene to open vehicle programming to everybody by simplifying vehicle software development and increasing deployment frequency without compromising safety and security. We believe this will create a whole new market of vehicle application developers who, through software, are able to integrate a vehicle into our daily lives in novel ways. Irene is a vehicle development platform with state-of-the-art tools, vehicle application programming interfaces, safety building blocks, which allow rapid iteration to shorten the time from concept to deployment. Irene enables developers and vehicle manufacturers to provide continuous value to customers through the frequent release of small software increments in an agile fashion. With Irene, a new vehicle software development cycle is enabled with modern software development tools and best practices. Irene provides developers with a comprehensive set of tools and services in order to get their ideas into an actual vehicle. Using Irene's carefully designed vehicle abstraction layer, developers will be able to deploy the same code to any vehicle running Irene OS, which includes middleware and a hardware abstraction layer. So today, vehicle software developers face a lot of challenges. We're hoping to solve some of these challenges with Irene. And here's a few important points to discuss today. First of all, the process through which developers develop for vehicles suffers from long planning and development cycles, and developers typically have limited opportunity to deploy and test their code. So developer agility is reduced, or opportunities for developer agility are reduced. Developers for vehicles need to work with a variety of proprietary and disconnected and unfamiliar tools. There is a steep learning curve moving from non-vehicle software development into vehicle software development. And again, things like the disconnected and unfamiliar and even proprietary tools are a big factor contributing towards that. The tools and services which developers use to build and test are usually quite limited in terms of options for scalability, in particular with respect to frequency of testing. Every line of code which a developer writes needs to be traceable all the way from requirements to code in the car. And every artifact which we produce from code to car needs to be immutable. We believe that through the use of GitHub Advanced Security, we can help solve some of these challenges. First of all, with respect to developer agility and the disconnected and unfamiliar nature of tooling, we believe that we can integrate as much tooling as possible into the familiar GitHub interface. So examples include integrating statuses through the use of Serif, and through the use of LGTM Enterprise, we can integrate the experience we provide to our developers in our GitHub environment back to our GitLab environment. Secondly, through the use of the CodeQL extension for VS Code, we're able to bring the static analysis scans that we perform via GitHub into the developer's IDE. And through the use of plugins for familiar and popular IDEs like IntelliJ, we're able to bring the GitHub experience into those IDEs. And super importantly for us, through the use of CodeQL, we can create custom rules for scanning important requirements and standards, particularly with respect to safety and security. So it's our goal to produce the world's safest vehicle. Safety and security are of critical importance to us. And as such, implementation of tools, workflows, and processes to both guide, simplify, and enhance capabilities to conform to and exceed the expectations of these standards is again of critical importance. Two standards that matter tremendously to us are ISO 26262, functional safety for road vehicles, and ISO 21434, cybersecurity for road vehicles. And rule sets which assist in compliance with these standards are AutoSAR C++ 14 and SCI Cert C++ 134. And we've engaged with GitHub to create CodeQL rules for scanning against these two rule sets and integration of those scans into the familiar GitHub interface and into the VS Code IDE, as I mentioned earlier. And it's our intent to work with GitHub to open source these rules for broader community use and more rapid adoption of our platform. And with that, I'd like to hand over to my colleague, Gwenn, to introduce you to Code to Car.
Yeah, thanks, Dan, for the introduction. So now I'm going to share what is the meaning of Code to the Car and the workflow associated to it. And I will talk a bit more on the technology beyond this workflow called Tekton. So now it's important to understand how differ a workflow for Code to the Car from a typical software delivery workflow. For common software, those steps or jobs are pretty well known. You check out your code, you do unit testing, then integration testing, and then finally you deploy, and you may have functional testing. Of course, this is a really general concept, and some workflow or pipeline may differ, but I think this is pretty accurate. Most of those steps are primarily synchronous, meaning the workflow don't really need to have a pause or long pause between step or job, and often do not involve human interaction or process validation. Obviously, sometimes it does. For example, if you use Terraform, you may have Terraform approval, but it doesn't really take long, just minutes or maximum an hours. Then the hardware or OS used for those steps are pretty common and we know Windows, Linux, virtual machine, mobile, nothing really fancy, and most of them can be provisioned through API or cloud provider API and so on. Now, if we look at delivering code to the car, this involves a lot of different steps. Of course, we do have the usual suspect, checkout, unit testing. But where the complications start to appear is when we need to do software simulation, which require a lot of CPU or GPU, a lot. Hardware simulation with specific hardware, which require a lot of effort to integrate. Same for this ECU, what we call electronic control unit. Basically, the same hardware as in the car, which you want to be sure your application behave as expected. And then, of course, after those steps, we need to do compliance check. And this is where GitHub Advanced Security is playing an important role for us. And for the last part, we have multiple manual approval steps, meaning asynchronous steps, like security approval, legal approval, safety approval, regulatory approval, etc. So to resume a bit, for the workflow code to the car, we need to integrate different hardware and process, which can be manual with human interaction or not. Simulation, again, we need specific hardware, which include sensor, for example, camera. For the software simulation, again, we need GPU and a lot of them. And simulation tasks could take minutes, hours, or even days to run. So we really need a way to pause the workflow. Same with the check and approvals. Most of those processes are manual and most likely interact with one or multiple persons. We can imagine even interacting with different companies. For example, a third-party company for certification. And then those checks include compliance. And again, this is where GitHub Advanced Security is going to help us. And for example, in Japan, we may need government approval to be able to add software to the car. So in our workflow system, what we are working now is integrating simulation and asynchronous process. As stated by Dan in the challenge slide, we need traceability and immutability. Everything needs to be traceable. Logs need to be, for example, logs need to be kept for X years indefinitely. And we need to be able to trace from the commit to the code deployed to the car. And then every produced artifact needs to be immutable. Logs, binary, coverage result, test result. Basically, everything produced during the workflow and by the workflow need to be immutable and tamper-proof. So we have built traceability and immutability as a core function of our workflow system. And for the technology to enable us to solve those challenges, we decided to use Tekton CD. So Tekton is a cloud-native CI/CD. It's a powerful and flexible framework. And you can deploy Tekton across cloud provider and on-premise system. The important point there is Tekton is flexible and it's the framework to build CI/CD. So one of the most attractive features of Tekton is this flexibility that the software gives us. We can basically fully customize our workflow and enforce our process. We consider Tekton to not only be a pipeline engine, but also a workflow engine. Again, Tekton is a framework. One of the things that we made clear in the precedent slide is that we need to be able to pause the workflow, which Tekton allows us to do. Tekton is built on top of Kubernetes. It's a kind of extension for the Kubernetes API, what we call custom resources definition. And one interesting feature is that Tekton can call other CRD natively. Like we have our own custom CRD. And this allows us to extend the workflow as we want. For example, again, approval process, specific simulation need. Basically, everything we want to implement could be a part of the workflow. Of course, because it runs on top of Kubernetes, it does support all the magic, Laravel, Node, GPU, scheduling, auto-scaling. This workflow requires to be scalable. And for the part running on top of Kubernetes, for example, the GPU, we just need to add resources to our Kubernetes cluster. And some of those steps could be complex, but thanks to the Kubernetes integration and the Tekton flexibility, this helps us to reduce the complexity of this workflow process. So now, I'm going to introduce a small example workflow where we have the following code QR rules. First, the security team can enforce and create their own rules. Plus, in the automotive, there is some standards. And for security, there is ISO 21434. And then, as a developer, you can bring your own rules. Next is GitHub give us some default rules. And one of the most important for us is the compliance and standard rules for the safety, which is based on the ISO 26262. So a bit more description there. What happens when the developer is pushing the code? From the time the developer pushes his code to our CI/CD workflow system, what happened in the building process? How we can enforce compliance and how CodeQL interact during this time. So in this very simple example, you can see on the screen, we have two repositories. One containing the mandatory rules, like security and compliance, meaning those rules will run every time and you can't change that. We enforce those processes. And the other one, the application code. So the developer will push its code, and then this will trigger a Tekton pipeline with three simple tasks: checkout, unit testing, and building. Again, this is just for example. During the building process, we will first check out the rules from the rules repository, and then we will start to initialize the CodeQL database, which is in the format serif. And then the main process happens. In this example, this is a C++ application. So CodeQL will analyze this code during the compilation. So once we get the compilation done, at the end, we will upload the CodeQL database to GitHub Advanced Security API. And then once the results are uploaded to GitHub, the developer will be able to check them. As you can see on the pictures, we have some interesting information. Of course, we have the issue itself. Then, as you can see in green, we have open, meaning this issue is still there and have not been resolved yet. Then we have warning. Warning is the level of the issue. And now, thanks to this information, we will be able to use, for example, the level as a gate in our pipeline. For example, high and medium level should be addressed before being able to move forward in the pipeline. And that basically helps us to detect and stop early on the process if needed. But at the end of the day, what really matters for us is to improve the developer experiences. We want the developer to focus on coding. We want to bring the same experience as developing a web application as developing a code to the car application. We want to remove the complexity out of the developer hands. So the tooling is integrated and developer has one place for the code to the car. The workflow by default is scalable and flexible. By default in the workflow again, we bring the safety, the security, the standard compliance CodeQL rules. And then, as I said before, traceability and immutability, it's a core function of the workflow system. And with that, I think we will improve the developer experience for Code to Docker. And then from that, I will give back the hand to my teammate, Daniel.
Thanks very much, Gwenn. So as you heard today, we have an exciting and challenging mission ahead here at TRIAD with our Irene product. If you're looking to take ownership and grow together as part of an exciting and dynamic team to make history, then I encourage you to look us up and learn about the roles that we have open here as part of our team.
Thanks, everyone. And please, if you want to check our website, you can find online, or you can follow this QR code or scan this QR code. And have a good day. Thank you.